Chapter 11.3, Perimeter and Area of Similar Figures. If you recall the definition of similar, if two figures are similar, the angles are congruent and the sides are proportional. So if you recall from Chapter 6, the perimeters of similar polygons, if two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So right here we have two similar figures. Okay, the angles are congruent and the sides are proportional. And they gave the similarity statement right here. And they wrote out the fractions for the ratios of the side lengths. And then in this fraction here, right here, they added up the side lengths. So this fraction right here is the ratio of perimeters. And as you can see, these over here on the right are the ratios of side lengths. Okay, so those are equal to each other. Now in this section here, we have two similar figures, the red and the blue. Okay, these are both rectangles, so opposite sides are congruent. And if this side equals 2, then this side equals 2. If this is 3, then this is 3. If you add up the sides, you have 6 plus 4, that's 10. So the perimeter equals 10. And this is 3t, this is 3t. This is 2t, this is 2t. Opposite sides congruent. If you add up the sides, 3 plus 3 is 6, 2 plus 2 is 4, and that makes 10t. So if you do the ratio of perimeters of the blue divided by the red, and they did that right here, the blue divided by the red, it's 10t over 10. The 10s cancel and you're left with t. Now, if you do the ratio of the areas, for the rectangle, it's base times height or length times width. So 3 times 2 is just 6. And the area is 6. And over here, it's 3t times 2t. 3 times 2 is 6. And t times t is t squared. So if you were to do the ratio of the areas of the blue to the red, it would be 6t squared divided by 6. And that's what they did right here. Okay, the 6's cancel and you're left with t squared. So as you can see, to get the ratio of the areas, you have to square it. So in Chapter 6, we established ratio of perimeters equals ratio of sides. Okay, but as you can see here, the ratio of the areas is the same as the ratio of perimeters, but it's squared. Okay, so basically, if you take either of these, I'll do it in a different color. If you take either of these, the ratio of the perimeters or the ratio of the sides, and you square it, either one, that is going to equal the ratio of the area, or should I say areas, plural. So that's what we're doing here. If two polygons are similar with the lengths of corresponding sides in the ratio of a to b, then the ratio of the areas is a squared to b squared. So these are similar polygons. This symbol here means similar to. All right, and apparently this side length corresponds to this side length. So if you did the ratio of the sides of polygon 1 to polygon 2, it would just be A divided by B. Okay, so the side lengths right here, 1 to 2 is going to be A to B. That's the ratio of the side lengths. Okay, and let's see, I'll write this out. Okay, so A over B is just the ratio of the sides. And we said previously, if you square the ratio of the sides, you are going to get the ratio of the areas. Now remember, when you square a fraction, you have to square the numerator and denominator individually. So if you square this, that's going to be A squared over B squared. So just take the ratio of the sides right here, square it, you'll have the ratio of the areas. And that works when you have polygons that are similar. Okay, example 1 in the diagram, triangle ABC is similar to triangle DEF. Find the indicated ratio. All right, part A, they want to know the ratio of the perimeters, red to blue. So since red is first, it goes in the numerator. So part A, they want us to find the ratio of the perimeters. But we said before that equals the ratio of the sides. Okay, so they said we're doing red to blue. So red goes in the numerator and blue goes in the denominator. And we see the side length right here on the red triangle. That's 8. And the side length on the blue triangle, that's 12. Divided by, reducing this fraction, divided by 4, that's 2. Divided by 4, that's 3. Now, the only thing I want to make sure if these are actually corresponding side lengths. So this side is BC. And this side right here equals FE. All right, let's make sure these correspond from the similarity statement, BC and FE. Now, if you look at BC, that's the last 2 letters. If you look at FE, that's the last 2 letters. So these sides definitely correspond. So the ratio of the perimeters is 2/3 based on the ratio of the sides. Part B, ratio of the areas, red to blue. So red is in the numerator, and we're looking for the areas. Okay, so we said the ratio of the areas is the same as the ratio of the perimeters squared. All right, we have to square it. So we did the ratio of the perimeters. We got 2/3. And we need to square it. And you square the numerator and denominator individually. So that's 2 squared divided by 3 squared. When you square the fraction, it gets applied to both top and bottom. 2 times 2 is 4. 3 times 3 is 9. Example 2, you are installing the same carpet in a bedroom and den. The floors of the rooms are similar. The carpet for the bedroom costs $225. The carpet is sold by the square foot, so in other words, based on area. How much does it cost to carpet the den? Okay, so they said these rooms are similar. The only thing we have to start with is the ratio of the sides. So let's do that and find the ratio of the areas. So we know that the ratio of the areas is going to equal the ratio of the sides squared. All right, so all we need to do is find that and square it. All right, so the ratio of the sides We'll do the larger one in the numerator. It doesn't matter. We'll do the ratio of the den divided by the ratio of the bedroom. I mean, the side length of the den. All right. So we're going to do the ratio of the sides and square it. So the side length for the den, this is the den. Side length is 14. And for the room, the bedroom, the side length is 10. Now, we can square it as is, but it might be easier to reduce it. So we have smaller numbers. They're both even. 14 divided by 2 is 7. 10 divided by 2 is 5. All right. So that's the ratio of the sides. And the ratio of the areas is going to equal that squared. So it's going to be 7 over 5 squared. You square them individually, top and bottom. 7 squared over 5 squared. And that's going to be 49 over 25. Okay. Remember, the den is in the numerator, room is in the denominator. Now, I'm going to set up 2 more fractions. Okay. And again, I'm going to keep the den in the numerator and the room in the denominator. Okay. Now, we said the price. They said the carpet is sold by the square foot. So, in other words, the price of the carpet is based on the area. And it said the bedroom costs $225. All right. So, this fraction here is going to be for the price. And this fraction here is going to be for the area. All right. Now, they're saying the price for the bedroom costs $225. All right. So the price of the room was $225. And we're looking to find how much it costs to carpet the den. So in other words, the price for the den, we don't know. We're going to call it X. For the area ratio, we did that already. So that was 49 over 25. We put the den in the numerator. So 49 over 25 with the den in the numerator. That works. Okay, and now just cross multiply. X times 25, top times bottom. That's going to equal bottom times top. 225 times 49. Solving for X, divide both sides by 25. Cancels here. I'll do this on the calculator. 225 times 49 over 25. And I get 441. That was a price. So the units are in dollars. Now, if you didn't want to cross multiply, you could have taken the ratio of the areas and said that the den is this much bigger than the room. So if you just took 49 over 25 and you multiplied that by the cost of the bedroom, since the den is this much bigger, you could have just done it that way. Okay, 49 times 225 divided by 25, and you would still get 441. So you didn't have to make the ratio fractions at the end, but some people it helps. You could have done it this way. Okay, please pause and try guided practice number 1. It says the perimeter of triangle ABC is 16 feet, area is 64. Perimeter of DEF is 12. Given that they are similar, find the ratio of the area of ABC to the area of DEF. Then find the area of DEF. All right, I'll give you a hint. I suggest you put ABC in the numerator, DEF in the denominator. Find the ratio of the perimeters based on the write-up, and then square it to find the ratio of the areas. All right, so for ABC, the perimeter is 16. And for DEF, the perimeter for DEF is 12. All right, so you want to reduce that to make it easier. You don't have to, but smaller numbers are generally better. 16 divided by 4 and 12 divided by 4. Now that's for the perimeter. Okay, if we wanted to do the ratio of the areas, we have to square it. So that's going to be 4 over 3 squared. Okay, and that's going to equal 4 squared over 3 squared. 4 times 4 is 16. 3 times 3 is 9. So that right there is the ratio of the areas. Okay, and they did ask that first, the ratio of the area of ABC to the area of DEF. So that means this one is in the numerator since it was first. All right, so we got that out of the way. And now we want to find the area of DEF. All right, so let's see. I'm going to stick with ABC over DEF. And we're going to make 2 fractions. The first fraction is going to be the ratio. And the second fraction is going to be the actual area. So we just did the ratio for the area. That's 16 over 9. Now for the actual area, they said that for ABC, its area is 64 feet. So for ABC, the area is 64. And for DEF, we don't know, so we're just going to call that X. We're looking for the area of DEF. Okay, cross multiply, 16 times X is going to equal 9 times 64. And the opposite of times 16 is divided by 16. The 16s cancel. You can do this on the calculator, but I know 64 divided by 16 is 4, and 9 times 4 is just 36. All right, the units were in feet, so for the area, it's going to be feet squared. Now, if you wanted a little shortcut here, to go from 16 to 64, you have to multiply by 4. So to go from 9 to X, you also would multiply by 4. 9 times 4 is 36. So that would have been a little shortcut. Example 3, a large rectangular baking pan is 15 inches long and 10 inches wide. There's a diagram. Smaller pan is similar to the large pan. The area of the small pan is 96 square inches. Find the width of the smaller pan. Let's take a look. All right, so we have our baking pans here. We're looking for the width of the smaller pan. Since the question mark is here, I'm going to assume that this is the width. All right, in which case, for this bigger pan, this would be the width right here. Okay, because they said these are similar. So they gave us the areas, all right? And we said at the beginning, the ratio of the sides squared equals the ratio of the areas. Now, since we're looking for a side length, we need the ratio of the sides, but we have the ratio of the areas, that equals ratio of sides squared. What is the opposite of squaring something? Well, that would be the square root. So this is squared. if we took the square root of both sides of this equation, this would give us the ratio of the sides. So we would need to take the square root of the ratio of the areas in order to get the ratio of the sides. So let's do that. All right. For the ratio of the areas, I'll put the larger pan at the top numerator. And I'll put the smaller pan in the denominator. Okay. So the larger area is 150. And the smaller area is 96. Now we could leave it as is, but again, smaller numbers are generally easier. Okay. These are both even. I'm going to reduce. Divided by 2 is 75. 96 divided by 2 is 48. Let's see. We can divide by 3. 75 divided by 3 is 25. And 48 divided by 3 is 16. Okay. So this right here is the ratio of the areas. All right, I'll just write it here. Ratio of areas. And we said the ratio of the sides is the square root of the ratio of the areas. So the ratio of the sides is going to equal the square root of 25 over 16. Now, just like when you square a fraction, when you take the square root, you do top and bottom individually. So it's the square root of 25 over the square root of 16. And the square root of 25 is 5. Square root of 16 is 4. Okay, that's the ratio of the sides. And let's see. And that's going to equal the actual side lengths. All right, we're going to make another fraction right here. Now remember, we put the large in the numerator and the small in the denominator. So we're going to do the same thing over here. We're going to do the large one in the numerator. And we're going to put the small one in the denominator. So let's check out the side lengths. We're looking at the width. The larger one is 10. The smaller one we don't know. We'll just call it W for width. So the larger one is 10. All right, the larger one is 10. And the smaller one we'll just call it W. Cross multiply 5 times W, or top times bottom, equals bottom times top. That's 4 times 10. Solving for W, just divide both sides by 5. Okay, you can use the calculator, but 10 over 5 is just 2. And then 4 times 2 equals 8. The units were in inches, so they stay in inches. Now again, if you wanted a shortcut to go from 5 to 10, it's just times 2. So to go from 4 to W, it's also times 2. 4 times 2 is 8. Consider two regular polygons with the same number of sides. All the angles are congruent. The lengths of all pairs of corresponding sides are in the same ratio, so any two such polygons are similar. Also, any two circles are similar. So if you have regular polygons, if you recall, all the angles are congruent and all the sides are congruent. So if you compare one polygon to another, one regular polygon to another, they are going to be similar. All right, as long as they have the same number of sides. If they're regular, the angles are all going to match, okay, but not necessarily the sides. The sides are proportional. Example 4, the floor of the gazebo shown as a regular octagon. Each side of the floor is 8 feet and the area is about 309. You build a small model gazebo in the shape of an octagon. The perimeter of the floor of the model is 24 inches. Find the area of the floor of the model to the nearest tenth of a square inch. All right, so there is no diagram, just a picture, but we don't need it. All right, they said the gazebo is a regular octagon, and they said that the model is also a regular octagon. So since they're both regular, they're both octagons, they're going to be similar. So unfortunately for the gazebo, the actual gazebo, they gave us each side length is 8 feet, but for the model, they said the perimeter of the model is 24 inches. All right, so we need to find each side of the model so we can do the ratio. All right, so each side for the model, let's see, the perimeter is 24 inches. And that's divided by 8 because an octagon has 8 sides. So each side is 24 divided by 8, or 3 inches. Okay, so that's each side for the model. And we're looking to find the area for the floor of the model. All right, so first we're going to do the ratio of the sides. We'll do the larger one in the numerator. That's going to be the actual gazebo. And we'll do the smaller one, or the model, in the denominator. Okay, so the ratio for the sides, the larger gazebo, the actual model, says each side is 8 feet. And the smaller one, we said each side was 3 inches. All right, so first of all, we need to convert to have the units match. 8 feet, we know that each foot has 12 inches. So in the numerator, it's actually going to be 8 times 12 inches, and the denominator is just going to be 3 inches. Okay, so we have the ratio for the sides. Inches over inches cancel, and we could use a calculator, but 12 over 3 is just 4, and 8 times 4 is 32. And the 3 canceled, so we're just left with 1 in the denominator. So that's the ratio for the sides. Now, we said before, the ratio of the sides, if you square it, you get the ratio of the areas. All right, so we need to square the ratio of the sides. So that's going to equal 32 over 1 squared. Okay, and that's 32 squared over 1 squared. Need the calculator. 32 squared is 1,024, and 1 squared is just 1. Okay, so that's the ratio of the areas. And now we can just set it equal to the actual area. So this is the ratio of the areas. This other fraction is going to be the actual area. And let's see what we were given. In the write-up, They said for the gazebo, the actual gazebo, which is the bigger one, the area is about 309 square feet. And we want to find the area of the floor to the nearest tenth of a square inch. All right, so we got 309 square feet for the area of the large one. So I'm going to write 309 square feet. And the area of the small one, the model, is just going to be X. We don't know it yet. All right. So if we cross multiply, top times bottom, that's 1024 times X. And bottom times top is going to be 1 times 309. Okay, divided by 1024 on both sides. It cancels here. And I'll do this on the calculator. Okay, I get a big decimal. So what I'm going to do, I'm just going to keep the fraction as is for now. 1 times 309 is 309. And that's divided by 1024. Now, that answer was in square feet. But they wanted it to the nearest tenth of a square inch. So we know that 1 foot equals 12 inches. And if you square both sides, 1 square foot, or 1 foot squared, is going to be 12 squared. 12 times 12 is 144 square inches. All right, so 1 foot squared is 144 inches squared. So in other words, we have to take this and multiply it by 144. All right, so we have 309 over 1024, and we're going to multiply that times 144. All right, and that's going to be in square inches. So 309 times 144 divided by 1024. Okay, I get 43.453. They said nearest tenth. So you look at the second decimal. If it's 5 or more, you round it up. So that's going to be 43.5 square inches. Okay, please try guided practice number 2. The ratio of the areas of 2 regular decagons is 20 to 36. What is the ratio of the corresponding side lengths in simplest radical form? I'll give you a hint. All you have to do is take the square root of that and simplify, make it a fraction. Okay, so they gave us the ratio of the areas. So the ratio of the areas is 20 over 36. And we know that that equals the ratio of the sides squared. All right, and we said before, in order to undo the squared, you just take the square root. So if you take the square root of the ratio of the areas, which is the square root of this right here, then you'll have the ratio of the sides. All right, so the ratio of the sides, and we said you square root a fraction, top and bottom are individual. So it's going to be radical 20 over radical 36. All right, and they said simplest radical form. Well, for 20, that's the same as 4 times 5. And the square root of 36 is just 6. Square root of 4 is 2, and we still have radical 5. And in the denominator, we have the 6. So 6 divided by 2 is just 3. And that's simplest radical form. So it's just radical 5 over 3. All right, please try number 3. It says rectangles 1 and 2 are similar. The perimeter of 1 is 66. Rectangle 2 is 35 feet by 20 feet wide. Show the steps you would use to find the ratio of the areas, and then find the area of rectangle 1. All right, I'll give you a hint. You want to convert it to inches because they gave you rectangle 2 in feet, and find the perimeter and area of rectangle 2. Start there and then set up the fractions. All right, so let's see. So for rectangle 2, they said 35 feet long. All right, so the length on rectangle 2, that's just going to be 35 feet times 12 inches per foot. And that equals 420 inches. And the width, instead of using Roman numeral, I should just write a little 2 there. All right, so the length of rectangle 2 and the width of rectangle 2, they said it's 20 feet wide. So 20 feet times 12 inches, that's going to be 240. And that's also going to be in inches. All right, so the perimeter for rectangle 2, it's going to be 2 times the length plus 2 times the width because it's a rectangle. So that's going to be 2 times 420 plus 2 times 240. And that equals 1,320. And of course, that is going to be in inches, okay, because it's a perimeter. And now for the area of rectangle 2, that's just length times width, or base times height. Okay, we said the length was 420. And we said the width was 240. On the calculator, I get 100,800 inches squared. All right. So let's see. They want us to find the area of rectangle 1. So we know that the ratio of the areas equals the ratio of the perimeters squared. All right. So the ratio of the perimeters, let's see. We'll do rectangle 2 in the numerator, and we'll do rectangle 1 in the denominator. All right. So for the perimeters, that is 1320 for rectangle 2. And for rectangle 1, the perimeter of rectangle 1 is 66. Okay, so that's for the perimeter. All right, and let's see. All right, if you take the ratio of the perimeters right here and you square it, I'm not going to bother to try to reduce it. You're going to have the ratio of the areas. All right. We said the area for rectangle 2 was 100,800. So rectangle 2 is in the numerator, 100,800. And the other area, we don't know. We'll just call it X. All right. So we can cross multiply as is. This is going to be 1320 squared times x. All right, so 1320 squared times x. And that's going to equal 66 squared times 100,800. Let me make more room. All right, that equals 66 squared times 100,800. Okay, dividing both sides by 1320 squared. And it cancels here. Do this mess on the calculator to solve for x. And I get x equals 252. The units were in square inches. So I was surprised it worked out to a number without a decimal, but that is the final answer.